Yeah, that's right. Yeah, I don't use that one. I use this visual and that one. But the next camera that's coming here is the facial recognition. Some kids are just they are searching for the whole class, trying to get some. All right, so watch here. So if you remember, we looked at the pendulum last day, right? I'm gonna go back a pendulum here, and I want you to notice a few things about the pendulum, right? So on top here is the wall, and if we displace a pendulum, the pendulum oscillates, right? The pendulum will oscillate between those 2 points, A and P. Everybody okay with that? Excuses, Western, I'm not seeing your boy, you know, kind of good. Put it down here. Where? Bring it here. Right, so watch here. So that pendulum will oscillate between A and P. Everybody okay with that? Yeah? Right. In simple harmonic motion, we have to look at two quantities and how they behave. We have to look at acceleration and how they behave, and displacement, how it behaves. Let's start firstly with displacement, right? Where is the equilibrium position there? See it? If you say it. Where is the equilibrium position there? If where? Dotted line, right? Let's call the point O. Right? So the further away we go from O, the displacement what? Increasing, right? Right. Something else also increasing. The further away we go, we set the displacement increasing, right? But by Newton's second law, there's also something called a restoring force. There's a restoring force that wants to pull the pendulum back to O. That's okay? So that restoring force is also increasing. Right? Marquis, if the restoring force increasing by Newton's second law, what else increasing? Newton's second law. The acceleration, right? The acceleration also increases. So we recognize that A is proportional to X. That's okay? But just down up. Look at it different. Wrong. No, correct. Right. What can you tell me about the direction? The direction for the acceleration and direction for the displacement. Are they the same direction? Right. So the acceleration going to the right, back to equilibrium, but the displacement going towards the pendulum. Right? So what does that mean? E and X proportional, but in opposite direction. That's okay? Once we could observe those two things, please. What that means that the object is moving with simple harmonic motion. So once you could observe those two things, the object is moving with simple harmonic motion. Are you okay with that? Yeah? What's something else? What's our next application where we could observe simple harmonic motion? Spring. A spring. Right? If you displace a spring, right, you'll observe those two things, displacement getting larger and acceleration as well. So if I give you a spring and I displace this spring, right, the spring will oscillate between these 2 points here, right? The spring will oscillate. So the spring will acceleration proportional to displacement and they take fate in opposite directions. So what that's saying there is that a spring is moving with simple harmonic motion. All right? And of course, we can do our little maths, take off that proportional sign and write a constant. The constant is omega squared. So therefore, for simple harmonic motion, we have that formula there. All right? Nice. But here's what we need. Here's what we need. We need to get graphs of how displacement and acceleration behave.
So why I
All right. Right. So here's what we need. We need to be able to sketch graphs for displacement and acceleration for something with simple harmonic. Right? I gave it already, but so that's right. So what's here? Let us see if we do what let's start to do this thing already. Somebody take my glass. All right, what's here online, right? So I want to try to get the graphs for simple harmonic motion, right? So I'm going to focus on the pendulum, right? That's the little wall there. The pendulum. I'm going to displace pendulum. That's the original position. This is the maximum displacement on both sides, right? So the pendulum oscillating like that. We want to try to get a graph of displacement against time. Right? Right? Let's start easy, right? Let's start with the pendulum being here. Right? What's the displacement here? 0. Correct? What would happen if I put it all the way here? Displacement is what? Well, the positive side, right? That's the negative. So here will be your positive displacement. So that'll be positive x naught. And then where will it go? Back to 0. And then it'll come here. It will go to negative x naught and then come back to 0. So that graph is what? A sine. Marquis is smart. I don't know why them fellas just see otherwise in the world. I know you're smart. Right? So if I had to write the formula for x, anybody can tell me what the formula is? Right? Something with sine. And the amplitude is what? Amplitude is x naught. And we can write theta here, right? But you all remember this? Angular displacement is what? Sorry. Angular speed is angular displacement on time. So theta is equal to omega by t. So I could also write that. Everybody okay with that? Right? So this here is the graph of displacement. Right? Can we guess on it? Or we can figure out how velocity is behaving, right? Or they should remember this. Everybody do that, man. Right. So if you have displacement earlier, right? Tell you. You remember kinematics? You remember kinematics? I gave you a little, well, come on, a little over me, right? But there was a little thing I gave you for displacement, velocity, acceleration. Remember that? Remember that? And it's all here. All right. Anyway, we'll in fact, how the link? Yeah, how the link? How to go from displacement to velocity? You what? Differentiate, right? So if you differentiate displacement, you'll get velocity. So if you differentiate that, you'll get a velocity graph. If you differentiate velocity, you'll get acceleration. Right? And the other way is an integration, right? But you wouldn't really get the integration in physics. Right? But I'll still give it integration of A is B, integration of B. Right. So here's what we need. We need to sketch the velocity. We need to sketch the velocity graph now. just in your hand. Right, but you can write it. You want to in that way, right? Right. I need us to figure out now what the velocity graph will look like. Pete will help us with this one. Pete, what the velocity graph will look like? Think about it. Think about Pete, the pendulum moving. Where is velocity the greatest? Marquis. Come on, sit down. Yeah. Pete. Velocity will be the because you're talking, Marquis. I'm Faith. Faith, what is the velocity? What's the velocity? What's the velocity at different points? Oh yeah. Think about no, I'll give it back. Just see this. Right, so slide it there, go on the board. Sketch the graph one time. Yeah, face. Come face. Go ahead. So first, before you do it, before you try to sketch it, right? Tell me what's the velocity the object moving. What's the velocity here, here, and here? It moving here? No. So the velocity here and here is what? And the velocity here is what? Eh? Is it moving here? It moving? And the pendulum moving like this? Huh? Maximum. Okay. I wasn't here last week. Well, it don't matter. You know, you ever see a pendulum in the light? Oh. Right? So the pendulum moving like this, right? Say Page said the velocity here is 0, velocity here is 0, and maximum in the middle. Right? Remember, we did this when we did the kinetic energy and thing. So Faith, let's see if we can put together the graph, right? No man. So the velocity here is what? Maximum, right? So for your x by maximum, call it v0. For your x, right? Yeah. For your little x here down below here. Right? Because at 0 is that, right? Right. When it reaches here now, it starts here and then went here. When it reaches here, the velocity is what? Yeah. Right? So put 0. Like how I do it here. Right. Right, yeah. And then when it reaches here, where it going? We'll come back here, right? And velocity here is what? Maximum. So put but positive or negative maximum. It change direction, right? Oh, okay. Yeah. I'm just like it about negative v's here. When it reach here now, when it here will reach here, so it's what? All right, so put 0. And last one, come back here as well. Catch you guys. Catch you guys. Excuse me, do you take need, please? Don't need to know. And what graph is this? Cosine, right? So you will get V is equal to V naught cos omega t. Everybody okay with that? Yeah. And then the acceleration. Last one. See if draw this one, and see if you can do the acceleration. Do the acceleration from a place. You know reaching that. I don't mind. So we have displacement velocity. I want you to try to get the acceleration graph. Right, so we need the acceleration graph. Who have it? I just pass now to watch the acceleration graph. Who? No, you're not. I get that. Okay, I will see the acceleration graph. The acceleration graph, right? All right, so come on, do it. Come on. Right, so he could undo. Let's call here A naught here minus A naught. Come on, do the graph, come on. How many for one time? Wait. So you start in here. You start in here. Yeah, you're going, you're following this, right? So you're going here, then here. Going like that, right? So you're starting at 0. What's the acceleration at 0?
I would say maximum
Maximum at 0.
wait, this one.
Start in here.
Then I go
Right, so how about the acceleration, yeah?
probably
One,
I need to do that accelerate.
here's max,
Yeah.
and here's back to 0. So it starts at 0, right? Then you sure? Positive or negative? Remember when you hear it acting opposite direction.
Yeah, so
Then write the formula. Kind of graph is up. But there's a sign, negative sign.
So
A is equal to, right, click number. People have to read it online, I know. All right, online say a graph will look like this, right? A is equal to
equal negative.
Javid, you have all this?
Side
Right. So those are the graphs, right? Those are the graphs of displacement, velocity, acceleration for something moving with simple harmonic motion. All right. But here's a slight problem, right? We need to be able to find V naught. We need to be able to find A naught. So the math people are needed to differentiate this. I need you all to differentiate this, right? So we're gonna take a look now by differentiation. Please differentiate this. Differentiate x. Can I ask this? So I want you to differentiate to get z, differentiate to get right, differentiate this to get this to get this. Oh yeah, try and differentiate them, please. Let's differentiate that fast. You are saying the wrong thing for this one. You are saying the wrong thing. Right, so watch this here. Watch this here. The differential of sine 2x. If you differentiate sine, you'll get cos. If you differentiate 2x, you'll get 2. And then write back 2x. Okay? Differential of cos is minus sine. Differential of 2x is 2. 2 by 2 is 4. Then write back 2x. Okay? See, we are helping you here. Differentiate this, this, and this. Remember, you have to differentiate here and bring it in front. Right, like because somebody who online here, Katrina doing a work for sure. Garage, what was the differential of x? The differentiator. Or just right up at the same time. Which you share? Garage, I mean, I think Vichy, I mean garage. Solid. Right? How you differentiate eczema? Pick you up and differentiating. All right, what you on, right? Pay attention. Right, so when you differentiate this, the differential of sine is cos, the differential of omega t is omega. So you're multiplying omega by what you had, and you write back omega t. Right? What's the differential of cos? You'll get minus sine. The differential of omega t is omega, so you're putting the omega by omega. You'll get omega squared x naught. Right? So if you look at these formulas here, right? If you look at these formulas here, you'll be able to find you'll be able to find V naught and A naught. Maximum velocity and maximum acceleration. Emily, could tell me what is maximum velocity, Ash? What is maximum velocity? Look at it, look at these here. Look at what you have and tell me where you think is max velocity. What is V naught? It'll be omega alone. Omega x naught, right? So your max velocity is omega x naught. By comparing, so there's the formula for B and there's the formula for B, right?
Yeah.
Yeah, see that tremble. Yeah. Well, I was saying that. Yes. So by comparing what's in front of this Marquis, we got V naught is omega x naught. That's okay? Right, Marquis. So tell me where's E naught? Yeah.
Because it's omegas, negative omegas.
Negative omega squared x naught. Right? So you'll see by going through the graphs, we technically proven simple harmonic motion. You're seeing that? Remember, we said for simple harmonic motion, this is A, right? Nice. So you know how to get the graphs. If you can't differentiate, you want to learn all of them. Okay? But here's the problem. I want to ask you. Dylan, we have a slight problem. All these graphs work for when we start at equilibrium. All these graphs, right? When you start at equilibrium. But remember, we could also start it here at maximum displacement. How do you think the graph will change? So if instead of starting at equilibrium, we start at maximum displacement, how do you think the graph will change? Once you figure out the first one, right? Once you figure out the first one, start at maximum displacement. You'll figure out the rest. You gotta do a job with that. Think about it. Think about how the graph will look. Same way how I sketched these points for you. Try to quick see if you can figure out the first one and then differentiate and get the others. Figure out the first one and then differentiate and get the others. Figure out what that. Oh yeah. Was it good? No. No, I see.
Yeah.
Yes.
Yeah.
Was it first? Can I follow it? So when you start at maximum displacement, would the graph start here or here? It will start up here, right?
Yeah.
So the graph is a what?
Plus.
Right, no, but remember to look like this, right? We start in here at maximum displacement, then we go into 0, then negative x, then back to 0, then here.
And then the velocity graph, it's a sine graph.
Right. So your displacement graph is x naught cos omega t. When you differentiate, you will get minus omega s naught sine omega t. And when you differentiate again, you'll get minus omega squared s naught. So those are the two types of graphs of simple harmonic motion. All right, let's go back to the note and let's try some particles. Yeah, you gotta write maximum displacement. You write the three formulas for maximum displacement.
I don't understand.
Now do everything else. You didn't know. So you can figure it out. Right, so please remember, for maximum displacement, what the formulas look like at the graph and for the starting equilibrium position, right? Right, make sure you can read off omega in the formula or time in the formula and so on, right? Let's go back to the handout. As we're rally, pay attention. Yeah, okay. Right, so remember, we talked about angular velocity, we talked about all of this. We talked about simple harmonic motion. Please remember what omega is, right, Kevin? Omega is what again?
But
Omega is 2 pi f or 2 pi f period, right? Right, here's a graph showing simple harmonic motion, exactly what we just talked about. But this is a straight line graph, right? This is acceleration versus displacement, not versus time. Right, so your graph looks like that. When your displacement positive, right? When your amplitude negative, your acceleration positive. When your amplitude positive, it is your acceleration negative, right? That's what the graph showing you, things that we know already, right? They use A instead of X naught, right? X naught means amplitude. Right? We talked about all the graphs. Here's a table of all the graphs. All the formulas, sorry, and these are all the graphs, right? You have them in your notes, right? Nice. So we also talked about velocity. Right? The formula for velocity, and here's a formula to find the velocity at any point in time. And I told you that maximum velocity is v is equal to omega x naught. Remember that?
yes.
Right. So look at this weird looking formula there, right? What has to happen for velocity to be maximum, Gavin? By looking at that formula, circle them, Gavin. What has to happen for velocity to be maximum? What's the formula and what is velocity? What has to happen? This is max velocity. Something has to happen in this formula here for max velocity to occur. Remember, x naught is the amplitude, x is any displacement, right? What has to happen? What's the formula again? We talked about it while we were moving the pendulum. Something has to happen. Okay, look at the pendulum. When is it at maximum velocity? In the middle, right? Very good. Monkeys. Well, I must have seen about monkeys. It's fun. Right? Well, I must have seen. Yeah. Right? So x is equal to 0. So that's the equal back on it. Yeah, I can see what. Right? So yes, when x is 0, that formula turns into maximum velocity. Right? So that's it. Right? So when the displacement is 0, that's the maximum velocity, and we'll get to find maximum acceleration. All right. We'll come and do these small examples just now. Right? I don't know if you all remember this formula. Oh, sorry. You all remember this formula from possible pendulum period? Let's make a note of that now. We'll go through the proofs in a little while. I'll go through this just now, right? I want to do one small calculation. So just make a note of that. Period for an object moving with simple harmonic motion. Gotta get the yeah. Yeah. All right. So let's just try some small calculations and then we take a look at that pendulum, right? Right. Let's start here. Let's start here. Take a little reason multiple choice. So I'll give it a little chance to work it out here. Think about it. So they give you displacement and the way to find frequency. Right? So remember we knew what's omega, right? Omega is equal to 2 pi m. So you had to figure out now from that formula how you getting how you getting how you getting it. Finish. I don't call it fish. Finish. That particle started from the origin or started from maximum displacement. X is equal to E sine. Sine is at equilibrium, right? Good. Figure out omega and then find it. Right into the calculator, Jacob. Paano yun? Talented ka lang. What's it? 8. Yeah. So therefore, omega is this here. That whole thing there is omega. So it means that 0.4 pi is equal to 2 pi f. So f is equal to 0.4 pi divided by 2 pi. Pi will cancel and you will get 0.2. Nice. Katrina, you okay with that? With that, the whole cutter? Oh, that's a good idea. Okay, keep it going for them. You have any good ideas, okay? Any good ideas? Okay. Right, next one. Next one is one more graph. Which one is the answer? Hurry up, we did this last week. What's the energy? This is what we did last week. This will go to Australia. Just how much choice? Tell me the answer now. Online, you can message the answer. Don't worry. Which graph correct? That's the question. Which graph is correct? Huh? C, correct, yes. All right. Let's try part C first and then we'll come on to part B. Try part C. Hurry up. No, it's not multiple choice. I don't know. I don't know. Let's have them group together now.
Oh yeah, together. I say no, yeah.
Excuse me, yes, we do enough past here. Oh yeah, right. There's 2 by 10 to the minus 3. Right? Find angular frequency. That's omega, yes, angular frequency. Find omega and then find period and then find it. Oh yeah, do that quick. And let's take a look at Sorry. Wait,
Very good. I'll record, yeah?
โคตรแม่
Hey, I don't make it one of you. Wow, thank you. Well, yeah, you follow vegan by yeah, but I thought you very much the kind of thing. So you gotta. And I know no, actually, so I might. What? And I'm left because you need to go just yeah. I mean, you're right. Did he see him? Did he see him late? Okay, so the tree. Five. Yeah, tree. Five. Or it's going for 5F. Remember, F is also equal to 100. So, yeah, I see it. Yeah. It was
Yeah. Hurry up now, we have more to do. Right, so this value here is what? What is called that value there? Right, that value is the x naught, and 3 pi is your what? Is the omega, right? So omega is equal to 3 pi.
And then T is equal to.
Well, f is equal, it's after how you want to write it. Right? F is also f will be 3 pi over 2 pi. So therefore T is 2/3
Yeah.
exact value.
Yeah.
So 1.5 f. Right? You have the period.
Right, and then about 3.
Yeah.
Oh, it's all right.
Right? Next part. How we getting displacement at 1 second?
Good T.
Put T is equal to 1. Very good.
Very
Very good, Sylvester. Yeah. Frequency is 1.5 hertz.
Yeah, after that.
No, you're not doing that.
Oh,
Sometimes in some books you will see omega defined as angular frequency. Right?
yeah.
But if you're not sure, work out omega and work out angular.
So what is this?
I don't know what year this is. How we getting displacement? Sylvester said to plug in 1. The calculator has to be in what order? Has to be in radians. Come on again. When T is 1, what you got?
So.
Because 0? Yeah. Right? Next one.
So what you size?
Huh? Yeah, go ahead now. What up? Unit. Right? And velocity is what? Right here is where the original equations will come into play, right?
It'll be by 3 pi cos 3 pi by 1.
It'll be 3 pi by 2 by 10 to the minus 3 cos 3 pi by 1. Yeah, correct. Look it out, tell me what I get for B. Right, so number 1, either you can differentiate or get rid of the formula, right?
I get negative 0.019.
Negative.
Yeah.
What is negative what? 0?
0.0.
Anybody else get that? Check it out, see. Check it out, make sure. Got your mark. 0 point? Yeah. Check it back again. Actually, what is saying now? Try to make calculations. Katrina got minus as well. Make sure it's in radians, right? Yeah, it might be minus. But 3 pi. 1 pi, 2 pi.
Yeah, the request are the same.
Yeah, so it's minus 0.1.
0.019.
Alright.
And for acceleration.
2 zeros of 1 0. 0.00.
10. And for acceleration.
Anybody else get it? Check up the push that off now. Everybody get minus? Minus 0.019. Right. Without working out the acceleration, what you all think it is?
So, I think.
Yeah.
Let me get what you have to say.
Right now the displacement is 0. So what do you think the acceleration is?
It's been like 0. So yeah, so we have to wait, no.
Without working it out, what do you think the acceleration will be?
0. Because if the displacement is 0, then 0 over the effect will be 0.
But that's one way to look at it. The next way is if it had 0, it had the equilibrium position. And acceleration is 0 there.
And that might be better.
What's what's that guy with us? What's the other full time with us?
Plus 3 pi by 1. T is 1.
Then they're up top there.
Next one. Oh, material, so right. Huh?
You got away from.
I just wait, one away, I short that time. I just want to see what it looks like, but I don't mind. Right, so let's just go back to the problem top. It's a simple pendulum. A simple pendulum has a length 1 meter and a mass 0.5. It is hanging from the roof car that is traveling at 5, breaking a corner of radius 15. Find the period in both cases. Part 2, what we just said, right? It's now moving with simple harmonic. Giving you 2 minutes.
Which part you want to do?
You're doing part 1 and 2. No, ignore this here. I just highlight the formula that you might be using in one of the parts, not in both the parts. Come Sylvester, hurry up, hurry up.
Where this is.
Take that.
Where this is.
The same question. That's the part B. Right, so part two, right? Since it moving with simple harmonic motion, how we find period? Part two. I'll come back to part one just now.
Well, we could use the T equal to by
Square root of L on G.
L over G.
Right, but can we use it in part one?
So yeah,
I would say no,
why is it?
because it's not moving with simple harmonic motion as yet. How is it moving? Let me see who can piece it together. How is it moving? It's moving with? They give you a radius and velocity and circular motion. So although it's not making a full circle, it's moving with circular motion. Right? So you have to remember your module one here to figure out.
Yes.
Yeah. And module two question it.
Yes.
Right. We must do it right. The man says in the wrong module, right?
I'll do that.
People just do that. We will write all kind of nonsense as people. Like,
See,
it's kind of yeah, man, right? Can't be cool, but not be all correct. Yeah.
So you go.
I got any so like no not that
I'll
actually.
get guys, but
I Jamaican so like man say and he rhyme man. I can't remember the whole thing but basically I say still and study for this people. Trying to call that it was some what's the man like every formula you know. Little space like that, everything you know in that little space.
In the example.
I'll write that.
No, no, on that paper, everything that you know for period, you write it down.
Yeah, because
Everything you write.
and everybody the exam, I'm sure. Crowd know every formula I'm responsible.
See a long thing in the back of your book. Man gets bro, I think man right. So you have to remember you have to remember how to get period, right? So T is equal to 2 pi omega, that's period. So we need to go back and work out this, right? You all remember how to get omega for circular motion?
That's what's in the last one. I just not gonna.
Yes, sir. Right.
So you're using P is equal to R omega. Right? They gave you a B, the velocity is moving up, and the radius. And then use that to find omega. Okay? Right? So you have to identify that you needed to use circular motion here. Right? That was kind of I was
No, sir, I realized that at signature, every time they give us the readings, right? And bank in, right? I was like, oh god, and that's when I realized because you know it's not so.
okay. Oh yeah, find what periods please. And say which one shorter, which one longer. So that's how you have nine. That one then. Huh? You have to book out two parts, part one and two. Yeah, but you still have to.
I guess it's bad. Hey.
653. It's a really good. Yeah.
Right? What's all got for the first one?
6-5.
6.
5. 5.
So what is that? That's 5, 1, 15, right? So
Yeah.
that's 1, 2. Okay. So that's 6, 5 seconds. And the next one is what? What's the next one?
3.
When it worked out?
Yeah. No, I'm sure.
2 pi by the square root of 2 and 2 on 9.8.
Yeah, basically.
So, yeah. Wait, look at the last one. Alright. Right, so I guess it was shorter, right? The period was much shorter during simple harmonics. Alright, nice. Alright, last one here. Right, we don't have much time, so just tell me what to do, right? Take a little read here. Jump in and tell me what to do. You'll do part 1. Part 1.
Yes.
Right, so they gave you the formula, Javed, and they want you to what? Calculate the period. Given that the velocity is given by that. And they give you maximum speed and they give you amplitude. Okay, times period again. Period is what? 2 pi over omega, right? Right. Look at this formula here. When does maximum velocity occur, Jacob? Because the question gave you maximum velocity. When does maximum velocity occur? In terms of the formula here. When does maximum velocity occur? When x is? When x is 0. Right? So maximum velocity is equal to omega by e. Can you find omega from this, Professor?
Yes.
Omega is what? It's maximum velocity over amplitude. Why is find maximum acceleration? Marquis. What's the formula for maximum acceleration? What you going to use? Marquis, come on, stand up here. Come on, face the wall. Come Marquis, the formula in both cells. Maximum acceleration.
Negative omega squared x squared.
Right? Do you have omega squared from part 1?
Yeah, omega.
Right, so you can find omega squared, right?
Yeah,
And do you have the amplitude?
I guess.
Yeah. Okay. So those are the things that we need to learn about simple harmonic motion, right? And I have one more part, but that's the graph that you also did last week. Right, so next week we'll continue from here and we'll do damping, right? I'll send this question on the group page and finishes.
Oh, yeah.